Okay, for today, for this topic, we're going to look at the refactory period. We will start with refactory period. So what does mean refactory period? Refactory period is defined as a duration of time. That is a duration of time which the neuron is incapable of repeating an action potential. So at this moment, no matter how you try to stimulate, okay, the neuron actually have no ability to generate the action potential. So we have two types of refactory period. One is absolute refactory period, another one is relative refactory period. So absolute refactory period actually refer to the depolarization and repolarization phase. Are you clear? Okay, I will explain to you guys why during depolarization and repolarization it belongs to this absolute refactory period, where no matter how you want to generate action potential, it is impossible at all, totally impossible for us to generate any action potential. Okay, now relative refractory period actually corresponding to the hyperpolarization, hyperpolarization, where if the stimulus strength is large enough, then action potential can be generated, but provided that the strength of the action potential, the strength of the stimulus is very, very strong. Okay, I will show you guys, I show to you guys what is meant by the absolute relative and relative, as an absolute refractory period and relative refractory periods. Okay, so this is a diagram show you guys. Okay, you can see that during this particularly depolarization, the rapid depolarization and repolarization belongs to absolute refractory periods. And then you can see that these hyperpolarizations, okay, can I see the hyperpolarization? So this hyperpolarization represent the relative refractory period. One thing that before we continue, you have to observe the timing here. So for one action potential to be generated from the stimulus until the end, can you see that? It takes about 3 to 4 milliseconds only. Are you clear? Okay, that's one concept that you need to know before we continue. Again, guys, it's in millisecond, few milliseconds, about 3 milliseconds to complete. So it's a very rapid change. Okay, so when I touch your, when try to imagine when you touch your skin, even though it's very brief and touch, it will be roughly about hundreds of milliseconds. Can you see that? Understand the concept? If I put it like this, guys, okay, when I touch yours, okay, you look at the on the screen, when I look at it, one dot, can I see that? One dot. That one dot already, even though it's less than 1 second, so you see that 1 second is very short, right? 1 second, okay, 1 second is very, very short. But now it's millisecond. Millisecond basically means that 1 millisecond actually equivalents to 1/1000 second. Can you see that? So means that the duration for action potential to take place actually is very, 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 very rapid. Okay, I have to repeat many, many times. Very, okay, because the concept later you need to know. Okay, the concept. Okay, so now means that if I give you one action potential like this, can I see that? One dot. This one will be for sure about hundreds millisecond already. Okay, hundreds millisecond. Okay, so 1 millisecond is very, 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 very short. Are you clear? Okay, you can start using a timer. Okay, if for example, the human reaction time roughly about 0.1 second. Okay, roughly about 100 milliseconds. That would be considered very fast already. Okay, 0.1 to 0.2 milliseconds, right? So it's 0.1 to 0.2 seconds. Okay, so that is considered quite fast already. Okay, so in this case, why we need to learn this? Because later when I talk about relative refractory periods, that is a bit complicated, very complicated in terms of the concept. Okay, now let us look at this. During the absolute refractory period, impossible for us to generate any action potential, because during this period of time, okay, action potential, all voltage gated sodium ion channel undergo inactivation spontaneously and rapidly at the peak of the action potential. So either they are already all open already, or all of them closed. And highlight, very important, what is the role of absolute refractory period? We want to prevent the action potential from being transmitted backward. Okay, I will explain this later when looking at transmissions. Okay, but don't worry about this part first. Don't worry about this part, but understand why. Why we cannot generate any action potential during this absolute refractory periods. Okay, so let me draw again the diagram. Okay, now look at this. This is time. Okay, so negative 65 millivolts membrane potential or potential different. So negative 50 millivolts threshold potential. Okay, positive 40, the maximum, okay, the magnitude that we can have. Okay, so initially we know that during the phase 1, okay, number 1, so maintain resting potential. Okay, I use a blue color. So maintain the resting potential. Okay, phase 1. So during the phase 1, okay, then we give the stimulus. Okay, let's say, okay, I prick you with, okay, or okay, prick you with the sharp objects. Okay, so what will happen here is when I prick you, so that is a depolarization. So we start with a slight depolarization, which is phase 2. So phase 2 characterized by some of the voltage gated sodium ion channel open, right? Some of them only. Okay, until we reach the threshold potential at negative 50 millivolts. What will happen here is when you reach the threshold potential, okay, when this receptor potential reach the threshold potential, then what will happen here is you have a rapid depolarization. So this rapid depolarization characterized by all voltage gated sodium ion channel open. Okay, so that is a start of the absolute refractory period. That is a start. So basically you can see that it shoot up very, very high. Can you see that? Okay, now during this period of time, phase number 3, during phase number 3, so phase number 3 characterized by all voltage gated sodium ion channel open. So means that at this moment, if I still continue to give the stimulus, I cannot make it more open already because the max all open already. You try to imagine the maximum marks you can have, okay, is 100 marks. Let's say 200 questions, but maximum marks is 100. So even though you score more than 100 marks, the max I can give you also 100, right? For example, if you look at a past year paper, okay, question say that, okay, this question have 3 marks, but you write 5 points, 10 points, useless. Because why? Maximum mark I can give you only 3 marks. Can you see that? So same goes to our neuron. During this period of time, you already achieved the maximum number of the voltage gated sodium ion channel to open the channel already. So it means that if you give them a stimulus again at this moment, you give them a stimulus again, useless. We won't be able to actually differentiate it at this moment. Are you clear? We won't be able to differentiate it at this moment. Okay, so useless. Now, after this membrane potential reach positive 40, immediately all voltage gated sodium ion channel close already. Okay, they close. So then you can see that there is a leak out of the potassium, okay, through the voltage gated potassium ion channel. So therefore we enter into phase number 4. Okay, phase number 4. So at phase number 4, can you see that again we also cannot, okay, at phase number 4 we won't be able to generate any action potential because at this moment all voltage gated sodium ion channel, they are closed. Are you clear? What's this mean? Means that all closed already. For example, I tell you, okay, time's up already, stop writing, and you, okay, submit your paper. So at this moment, after this moment, okay, I say that at this moment, right? Okay, stop. Okay, reach positive 40 already, time's up already. You have to submit your paper already. After submission of paper, then you suddenly tell me, oh, sir, I know how to answer the question. Can I give you the mark? I can't give you the marks. So same concept here means that now already enter into phase 4, which is the repolarization, characterized by all voltage gated sodium ion channel closed and all voltage gated potassium ion channel open. So therefore, at this moment, if you give any stimulus, again, we won't be able to generate any action potential. So during this green zone here, okay, we term it as absolute refractory period. Okay, absolute refractory period, where at this period of times, once action potential is generated, we won't be able to generate, so impossible to generate any action potential. Are you clear? So no matter how strong or what is the stimulus, impossible for us to generate the action potential already. Are you clear? Okay, phase 3 and phase 4 means that is the neuron now under this absolute refractory period. Okay, now next. Okay, so followed by what? Because we do know that phase 5 hyperpolarization. So hyperpolarization, okay, is undershoot. Okay, it's undershoot. So this hyperpolarization, because of the voltage gated potassium ion channel closed slowly. So therefore, we need to make sure that it return back to the resting potential only. Okay, so at this orange color zone here, this part represents the relative refractory period. Okay, relative refractory period. So relative refractory periods, can I generate the new action potential? The answer is yes. Okay, provided that the strength of the stimulus is very, very strong. Okay, so now the duration of times. Okay, if you look at duration of times, do you need to take a snapshot? Can take a snapshot here. Then I will go back to the duration of timing then and show to you guys. Okay. Can I? Okay, now come back this. Okay, now if you look at duration of times here, this one, when the duration between, okay, can I say that duration between the rapid depolarizations and repolarization is fixed, roughly about 1 second here, 1 millisecond, sorry, roughly about 1 millisecond. Can you see that? Roughly 1 milliseconds when you have the rapid depolarization followed by repolarization, roughly about 1 millisecond, and this is fixed. Are you clear? But the timing for this hyperpolarization, okay, it can be shorter or longer. It can be shorter or longer depending on how fast we want to generate back the resting potential. So here come in another concept here. If you want to generate any action potential, you must start from the resting potential. Are you clear? It must start from the resting potential. So means that if you look at this hyperpolarization, if my stimulus is strong, I will be able to shorten the time and immediately generate the second action potential. So we say that because we do know that in all or none principle, no matter how strong the stimulus, okay, the maximum, the amplitude here, the maximum here, always positive 40. Okay, change the diagram here. Okay, we have to match it with our syllabus. Okay, but it doesn't mean that the diagram is wrong. Okay, but now you can see that, guys, as I said, that no matter how strong the stimulus is, it always maximum at positive 40. That's all. Are you clear? So how our brain actually interpret the signal is strong or, okay, how we interpret the signal is strong or weak signal based on how many action potential reach your brain per unit time of frequency. Because if the stimulus is strong stimulus, what will happen here is you will be able to shorten, okay, the relative refractory period. So means that instead of having this long, then immediately I can have a second action potential immediately. So means that very fast I can generate the second action potential because I can shorten this relative refractory refractory period. So the more action potential I can generated, the brain receive the signal, oh yeah, so many action potential come in at the same time. Okay, almost the same time, I know it is a high strength. Okay, but if let's say the stimulus is very, very weak stimulus, like gently touch, so it means that you may see that I may need the more times to reach the actual resting potential, only I can generate. So it means that the frequency here will be low. So low frequency represent the low strength. So it means that the durations of the hyperpolarization or this relative refractory period basically determines how strong, okay, and the brain will be interpreted based on this, and how strong we will be how strong these stimulus can be. Okay, so this is general parts. Later when we go to the application, you will be able to see it. Okay, so relative, when we talk about relative refractory periods, okay, so firing of the second action potential is possible. Okay, if the stimulus is strong enough, the excitable membrane can initiate a second action potential. So it must be strong. Okay, a strong stimulus produces a rapid successions of the action potential. Are you clear? So what's mean strong? Strong means that I can generate many action potential at a particular time compared to the weak stimulus. So weak stimulus only can produce, let's say, for example, 5 per unit time, but strong can produce 10. So this is how our brain interprets. So basically the length, highlight this, the length of the relative refractory period so determines the frequency at which action potential are transmitted along the neuron. Okay, so write down. If strong stimulus, so higher frequency. Okay, weak stimulus, so low in terms of frequency. Why? Oh, sorry. So all of them deal with the duration. Okay, duration of what? Durations of the relative refractory periods. Okay, relative refractory periods. Okay, I will show you guys later when we enter into this part. Okay, today. Okay, so we have done for this one already. Then we continue with this propagations of the action potential. Okay.